we'll start the basic programming, like how NO and NC connection works. Then we'll draw the ladder diagram for basic gates. Okay. So now let's see how switch works like. Okay, NO contact, how it will work. So now whenever this is the rail and this is the run. Let's say I am using a NO connection. So if I make switch on, what will be the output? If switch is made on, what will be the output? On or off?
On, madam.
Okay. If it is made off, then what will be the output?
Off.
Madam.
Oh, okay. So next is NC. So this is the symbol for NC. Okay, if I make it on, what will be the output?
Off.
If I make it off, output will be
On.
okay. Now this is nothing but NOT gate. Okay.
Okay.
So now let's try for AND gate. So now how many inputs are there in AND gate?
It's 2, madam.
So A and B, 2 inputs. How many outputs are there?
One output.
1.
One output is there. What are the conditions we have? When it is 0, 0, output will be
0.
0, 1,
0,
0.
1, 0,
0,
1, 1.
1.
1.
Okay. Now I have two switch, correct? How I need to connect it, whether in series or parallel connection?
Series.
Why series? Can anyone tell? Mallikarjun, don't answer. Others. Why I need to connect it in series connection only? Why I cannot connect it in parallel?
Both the input high means, madam, output will be high. That's why.
Okay, in parallel condition also, if I connect, if both the inputs are high, that time also output will be high, no?
That one for
Parallel?
R gate.
Tell. Someone was answering parallel. Why not parallel?
In parallel, if you switch off one, it output will be on.
Correct. So in parallel combination, if any one switch is on, the output will be on. Therefore, whenever we are realizing the AND gate, we need to connect the switches in series fashion. Okay. Now we'll go for OR gate. Should I need to write the condition? No need, right? Okay, parallel or series connection?
Parallel.
Okay, so you guys know about parallel and series connection now. Now, please, everyone, draw for NAND and NOR gate and send me the pics. Did you people finish it? If you guys are in office, no need to send others who are in room, home. What about you people? No one are responding. Am I audible? Guys, am I audible to you people? Are you there? Anyone?
Yes, madam.
Hello. Ma'am, which one, ma'am?
NAND and NOR.
Yes, ma'am.
Finished, huh? Share the pic. Share the pic.
Okay, let me.
What about others? Mantesh, correct. Okay, Shushanta, NAND is correct. Radha Krishna, please name it, no? What series, parallel? Name them, which gates these are.
You go on and parallel and
Okay,
series.
what about Mahantesh? Now it's correct. Radhakrishna, please name it. Don't just mention it series or parallel. Okay, this is assignment for you. Srinivas, it will be assignment for you, but don't check it out. Okay, just try to do it. Gavi, you have any idea? Because this is your first sessions, no?
No, ma'am.
Okay, so I'll explain. Now, whenever we write for NAND gate, we'll write the truth table first. It will be better to understand. Yes, Srinivas, we have to make all the gates. So let's write the truth table. Sorry. Gavi, please tell me the outputs. If both the inputs are 0, what will be the output?
1, ma'am.
If for 0, 1,
1.
for 1, 0,
1, ma'am.
for 1, 1,
0, ma'am.
okay. So now see, for
Yeah.
not conditions, the output is high. Okay. Whenever if you're not getting to realize any condition, just check out whether it has a plus or dot. If plus is there, then it will be a parallel connection. If it has a multiplication operation, then it will be a series. Okay. So there are many different ways to recognize it. Okay. So whenever you encounter plus, it will be parallel connection. Whenever you encounter a multiplication sign, then it will be a series connection. Okay. Now, since it has a plus, but with that, it is not A, it is complement of A because it has A bar. So therefore, I have to use a NC switch. Okay. Okay. So now, since it is a plus mark, I have to use a parallel combination. To use NC or NO switch, since it is a complement, since it is a NOT operation, I'll be using two NC switches in parallel connection. Okay. Okay, where you got confused?
What we need to use for if we get A bar plus B bar like that, ma'am.
See, whenever if you have any plus mark or addition, okay, that time you have to use parallel connection. Okay, in binary, whenever you encounter addition
Okay.
symbol, that time you have to use parallel connection. See here.
Okay, ma'am.
In AND gate, what have we see? In AND gate, we have used two switches in series. Why? Because it is a multiplication operation, correct?
Yes, ma'am.
Now, in the OR gate, we have used parallel combination because it is a plus addition operation, correct?
Yes, ma'am.
Now, this NAND gate is complement of AND gate, correct? But when I take the expression of AND gate, so it is A into B, since it is followed by a NOT gate, because the symbol of NAND gate is like this, the basic symbol, okay? Here you will get A into B. When it is passed through NOT gate, you will be getting A dot B whole bar, okay?
Okay, ma'am.
Now, for this operation, you cannot realize it in the logic, ladder logic, okay? Because it is A, B, it is acting like a one term now because of this complement, okay? Now, based on De Morgan's principle, whenever there is a multiplication and a complete bar, I can convert it into individual NOT operation with the addition mark. Okay. Now, this AB is a two individual terms added together. Okay. Understood?
Okay, ma'am.
Okay. So, therefore, we'll be having a parallel connection. So, this is one way to understand. The other way is based on this condition. Now, see here. It is 0, 0. whenever whenever the condition required is low, you're getting high for low conditions, that time we have to use NC switch. Okay. Whenever you see a high condition for a low states, then you have to use a NC switch. Okay. Now, to use it in parallel or series connection, you have to check for any one zero condition, the outputs are getting high, or only for one condition the output is getting high. If for any one condition the output is getting high, then we have to go for a parallel connection. Okay. Understood? Should I repeat again?
Yes, ma'am.
Okay. Now see here. Now we understood that whenever the output is getting high for zero condition, we have to use NC switch, correct? Gavi Siddhappa, I'm explaining to you only.
Okay, ma'am.
Okay. So see, whenever we have a low condition and you are getting a high output condition, then you have to use the NC switch. Okay. Now, to use them in parallel or series connection, you have to check whether for any one of the low condition, the output is getting high, or for only low both for only one particular condition, the output is getting high. Okay.
Okay,
Here
ma'am.
in NAND gate, for any one condition out of 4 condition, if any one condition zero condition is there, the output is getting high. Correct.
Yes, ma'am.
And for if both the inputs are going high, output is becoming 0. Okay. That time I'll go for parallel combination. Okay. Because the current will be flowing like this. When I make both the switches on, the connection will get break and the output will become off. Okay.
Okay, ma'am.
Understood?
Yes, ma'am.
Now can you try NOR gate? Gavi Siddhappa, are you able to do it?
Yes, ma'am.
Okay. Should I connect NC or NO switches? Should I use NC or NO switch here for NOR gate?
NC, ma'am.
Okay. Series or parallel connection? You have a multiplication operation here. So series or parallel?
Series, ma'am.
Okay. That's all. Done. Okay. Understood?
Okay, ma'am.
Okay. Now we'll wind up the today's session here. I want this for XOR and XNOR gate to ladder diagram. Okay. Please draw it and share it in the WhatsApp group. And I will give 2 more homeworks. I will share the question in the group and try to solve them also. Okay. Is it okay? Guys, is it okay?
Yes, ma'am.
Okay. Gavi Siddhappa, I will write the expression for you. Please check it out. Okay.
Okay, ma'am.
For XOR, you will get A bar into B plus A bar B. And for XNOR, it is A bar into B bar plus AB. Okay. Try to solve them. And 2 more homeworks, I will be sharing it in the group. Okay. So, and please update me regarding the software installation also. Okay. Guys, please respond.
Okay, ma'am.
And if you make it fast,
Okay, ma'am.
from tomorrow onwards, we can start with the programming itself. Okay. Okay. Thank you all.
Okay,
You can leave the session now.